This is a session on SpiceDB, which is a mature hyperscale authorization solution. Before I get started and start talking about SpiceDB and get into the details, I want everyone to know who is speaking to them today. So I'm Jimmy Zielinski. I'm one of the co-founders of a company called authorize, and they're the creators of SpiceDB. Previously, I actually worked at Red Hat, so thanks Red Hat for putting on this conference. I joined Red Hat through the CoreOS acquisition, so I have been working kind of in the cloud native and container ecosystem, basically since the beginning, pre-Docker 1.0, before the CNCF existed. I've created a bunch of projects in that space, contributed to a bunch of the foundations, and I'm even a maintainer of OCI, which is the standard for container application containers. I put up some contact info here. If you ever want to, if you miss your chance talking to me at the conference, if you want to shoot me an email, I try to respond to anyone that actually sends me emails. The slides are going to be available, uploaded to Prextal, I think is how you pronounce it, after the conference. Cool. So before we start, I'm going to level set on some terminology. I feel like every authorization talk is morally obligated to have this slide. There's this abbreviation that's used in industry called auth, and it always causes confusion. And that's because it's ambiguously abbreviating two different distinct concepts. Authentication, which is concerned with verifying someone's identity or like logging into a system, and authorization, which is basically being concerned with enforcing whether or not someone has access to perform an action on a particular object. And because these two concepts together form the foundation of application security, they're often discussed together. So you might have heard of the acronym IAM, which stands for Identity and Access Management. And so when you're having these technical conversations, it's really easy to misspeak, change the subjects implicitly, or even just use one of these vague terms. And that can cause confusion, and regularly causes confusion, if you're a beginner or an expert. It doesn't matter. I've seen some of the most senior people in industry confuse these two. Thus, I tend to prefer these terms, and my company, we use these terms instead, which are identity and permissions. I think these are far less ambiguous. If you have a non-technical audience, even they can kind of understand when you use these terms. And so throughout the rest of this talk, I'm focusing purely on permissions. SpiceDB doesn't handle anything related to verifying identity. It actually works with anything that you decide to use as a technological solution for verifying identity, because everything with regards to permissions happens after you've verified the person's identity. All right, with that out of the way, we can tackle the main problem, like the reason why SpiceDB exists, which is that app permissions are hard, but everyone has to do it. To build modern software, you're going to have various users interacting with your software, and they're going to have varying degrees of access to the resources being managed by the software. All of that is going to be security critical code that your application authors are writing. So let's just do a quick check-in. How good of a job are they doing? Well, if you're familiar with this foundation called OWASP, they're a nonprofit that basically evaluates the security of basically security practices for application web development, usually, specifically, every few years. And they have this list called the top 10. And in 2017, broken authorization was number 5. By 2021, it's now become number 1. This is ahead of supply chain security. So you'll hear a lot of buzzwords about supply chain, but actually how most people are getting impacted with vulnerabilities in their software is actually related to broken access control. So why is this the case? Basically, most of industry, when you're building your basic web application, you write some code similar to this. Just want to make sure everyone can kind of read that-ish. It's not super important that you see the exact details, but basically you have your relational database that your web app is using, and you're going to query that, and then you're going to interpret the results of that query. And at some point, this strategy is going to fall over. Whether you basically didn't design that foundation to support something more complex, and that impacts latency. For example, if you're using a relational database and you find you have to join on 10 tables to get your answer for your authorization data, you are going to bump into that, and that's going to cause you to refactor that code and completely reorganize it. Or you'll have customers that request a new feature, and that new feature isn't possible unless you refactor your authorization code. For example, maybe people want to add point-to-point sharing for individual resources in your application. And this adds complexity that you didn't account for. You could also have a completely different problem, which is almost non-technical. You could find out that your business needs to target a new market across an ocean. And because your primary database lives in one continent, but the new market lives in the other, it's going to be prohibitively latency expensive for you to query that main database across that ocean. And then when you finally go to address these things, like refactoring the code or maybe making a replica in a different continent, most of the time, this math is kind of fudged, but most of the time, it's going to take you a decent amount of time, longer than normal feature development, to refactor that code because it's security critical. There's probably only one or two engineers that really, really know that well enough that they're confident to make a change to that code. And then you're going to have a long QA turnaround because not only do you have your typical QA, but often if you're deploying to enterprise environments, you need to have a security audit before you can actually launch this change into a secure environment. And then on top of that, if there actually is a problem in that code that you're going to introduce, you really don't want to introduce it and expose all of your customers to it immediately. So you're probably going to do a progressive rollout where only small portions get access first. So that is going to be even more time spent on your typical deployment if you're not already kind of doing progressive rollouts based on risk. And all of that could, at the end of the day, yield you just one permission. All this is worst case. But fundamentally, the thing I'm trying to get at with this slide is that security becomes at odds with development velocity in this model. And you're going to want to take shortcuts, but if you take a shortcut, it's going to be a security flaw. And then rinse and repeat. You have no idea how long until you get the next feature request from your product manager or customers that says, hey, we really, really need this thing. And you have no idea if that's going to cause you to have to refactor all that code. You could not even be done refactoring it from the last time before you get one of these requests, and you have to completely rethink the conceptual model that you've built for your authorization system in your application. All right, so how do we fix it? And I think heroes come in mysterious places. Does anyone remember what this is? Does anyone know what this is? Just shout it out if you know. Correct, yes, is Google+. And so Google+, I don't know if it's the chicken or the egg in this scenario, but Google+ had this feature that was called circles. And unlike something like Facebook or LinkedIn where you just kind of like directly connect or become friends with someone, Google had this cool idea, which was you bucket people into different groups, and then you could share to different groups and kind of mix and match those groups when you share content with them. Well, that gave birth to the internal authorization system at Google. So in 2011, they started this project internally called Zanzibar. And basically, I like to joke that there's only two things that were good that came out of Google+. It's Google Photos and Zanzibar. Most people know Google Photos, but they don't know Zanzibar. But what ended up happening is they designed an authorization system that was flexible enough to support that circle functionality in Google+, and ended up adopting it across the entire business. So there is an internal Zanzibar service now at Google, and Gmail uses it, Google Drive uses it, and the idea is that, well, okay, so the reason why this paper is super novel versus all of the other literature in the authorization space is because it's not focusing on one particular paradigm or concept with regards to modeling authorization systems, but it's actually documenting a cohesive live running system at a hyperscaler. So it just describes the whole system in its entirety and how it's being used even by the consuming applications. So that gives you way, way, way more clarity than most of the other kind of papers that are just telling you about an individual concept. The other major important thing about it is it tried to solve authorization with an eye towards distributed systems. It looked at it as a distributed systems problem. So if you notice the title of the paper, the title is Google's Consistent Global Authorization System. And that, if you're familiar with distributed systems, is a really hard problem. How do you have something consistent and globally distributed? And so that's what authorization systems need in kind of like the modern world. And to make this super concrete, if you have ever used a cloud provider or cloud service, when you log into the console and you go to the IAM service in Azure, GCP, or AWS, you don't actually pick a region. You don't say, I'm in US East 1, because the rules for your account are global. They span the whole continent. It doesn't matter what data center you're in. Your authorization rules need to work there. And in fact, Google Cloud IAM under the covers is a fork of Zanzibar that's specifically running just for Google Cloud. So this paper got published, and it inspired a couple other companies outside of Google, probably ex-Googlers there. So, but Carta and Airbnb are kind of famous for implementing these systems on their own, internal to solve their own problems. So fast forward a year after the paper came out, so in 2020, my co-founders and I left Red Hat, and we decided to create Alzed. Basically, we looked around, and we're super excited about Zanzibar, but folks were just kind of playing with it, and no one was really moving the needle towards making this a real thing that could be used in an enterprise or cloud environment. And so we decided that was going to have to be us. So after about a year of running that, building that and running it in production, we open sourced it, and we called it SpiceDB. And so SpiceDB is an homage to basically this theme of that's based on Doom, so Dune, the sci-fi book series, because back at Google, internally the project was named Project Dune, or sorry, Project Spice. So everything we do is kind of Dune related, and before kind of writing the paper, publishing the paper, basically legal told Google they couldn't call it Spice as that reference, so they named it Zanzibar, which is a spice island in Africa. So there's still kind of an homage in that name as well. But if we fast forward to today, SpiceDB is a thriving project. It has contributions from some pretty notable companies: Netflix, GitHub, Google, Adobe, Red Hat, Plaid, Reddit are just naming some of the contributors. And then we have production users in companies as small as just the co-founders, all the way up to Fortune 50, household tech names, and even some of the largest financial institutions in the world. So I haven't really talked about what SpiceDB is, so I don't expect anyone to know the individual boxes on this slide, but I kind of wanted to highlight this one important point, which is when you work at Google or a mega company, your boss can tell you, hey, you're building authorization, you have to use this thing. This is what we have for authorization. So you don't get a choice in this matter. But in the real world, outside of that environment, you have to tell people, or you can't just tell people, you have to convince them. So we had to take Zanzibar and read through the paper, basically patch over, fix any Googleisms that only apply to Googlers, but then also improve the developer experience so that people can understand that they're going to get something better than what they would build themselves, and that it's worth their time to invest in learning our solution and then advocating it internally across their other developers or other teams at their company to make sure that they're more successful. So we've had to do a lot of work, and actually it's kind of interesting. Every now and then we'll hear people attribute features to Zanzibar that were actually innovations that SpiceDB created. So there's kind of like joined at the hip where people are starting to conflate things that we've created and things that are in the initial paper. But true to the paper, SpiceDB has the same goal. We try to stay as faithful to Google's goals in that paper as possible. And so that goal is scale. Now, you might be wondering or thinking to yourself right now, I don't have scale. Not necessarily. We don't have millions of QPS flowing. We're not Google scale. But I think a lot of people forget that scale isn't just about traffic or requests per second. But I had the example earlier, geographies. You could have not much traffic, but have to serve 2 different markets across the world. That's a way you can scale. The number of features that you can support and your development team can put out, that's also a way you can scale. The development velocity, how fast you can actually ship new features, is also a way you can scale. And so SpiceDB is trying to tackle all of these things when it's talking about scale. And I think that there is kind of 2 major kind of foundational concepts in this paper that lend itself to getting this scale. And that's centralized authorization and ReBAC. I'm going to go over centralized authorization first. Centralized authorization is complex if you don't understand what authorization is. So I have this conceptual model. It's a little abstract, but I'll give you a concrete example as to how you can think about authorization generally. I break it down into 3 different components: models, data, and an engine. Models are kind of the rules that define and govern the actions that can be taken in the system. So they're kind of like static rules that you have, and you define those ahead of time. Then you have data, which is live. It could be changing. But this is the information about actors, actions, the object of the action, and any context related to that. And then you have an engine. And both of those feed into the engine. And the engine actually applies the models to the data to interpret, basically, and make a decision whether or not someone has access to a thing. The real concrete example is think of a courtroom. In a courtroom, the models are laws. There's laws of the land. They're kind of written in stone. That's what you are working with. And then there are facts and evidence in the case being served, right? That's the data. And then you have a judge or jury that applies the laws to the evidence and makes an ultimate decision whether or not someone has committed a crime. So if we take the example I showed earlier, kind of that code that most people write where it's just embedded in their application, and think of it in this framework, you're going to write some database models, basically, and they're probably going to be using your ORM or whatever kind of database framework you're given in your language of choice or web framework of choice. And then you're going to write some code that is quote-unquote engine code. It's going to be interpreting the results that you query out of your relational database, which is the data. But the big problem with this is what happens when you introduce a new application that needs to check these exact permissions. So service number 2 comes into the picture. And now, if service number 2 comes into the picture, what are you going to do with these models and engine that are deeply coupled into the code of your original service? Well, if you're lucky, both services are written in the same language, so you can kind of abstract it into a library, but you still have dependency management across that library. If you're unlucky, you have to copy that code altogether or rewrite it in a different language. And then you pray. You pray that the database for the original service isn't overloaded because you're querying it from an external service, and usually people consider that like a no-no. That's an API boundary. You should be talking to the API, not my private database. You have to pray that that database schema doesn't change out from underneath you. So maybe that schema changes, and the developers of the first service don't inform the new service that, hey, we changed our database, because that's normally a private thing. And then finally, this is one that a lot of people forget about. What if your new service is more critical than the previous service? So if the uptime requirements are higher, now you've actually brought something that previously wasn't in the critical path into the critical path. So you can have what's called a priority inversion there, and you can definitely have outages as a result of those mismatched assumptions. All right, so finally we can get to what centralized authorization is, which is to take all those things, the models, the data, and the engine, and put them together into their own service. And when you put them together into their own service, this gives you a bunch of new capabilities. Basically, any application can query it at any time. And I kind of list apps, microservices, your data warehouse, anything. You can centralize this across your whole business. And the only thing those external things querying the system need to understand or need to question is, does this subject have permission to perform this action on this particular resource? That's it. So if you need to change, they don't care at all how that thing got access or how that action was authorized. They're just asking the question. So if the how actually changes, if you say, I'm actually refactoring, there's going to be like now teams as an intermediary or groups of users, none of these applications need to know that, because they're just asking the question, can this person perform this action on this thing? So you get to change that in one place and change no code across your whole business, just that one change in SpiceDB. That's really, really powerful. And the way I really like to give people an example of a powerful integration that you get from this centralized service is one that Google actually uses themselves. If you open up Gmail right now and you put in a Google Doc URL to an email and try to email it to somebody, but you haven't shared it with them yet, Gmail will actually pop up a warning and tell you, hey, you didn't share this yet. Do you want to share this with this person? There's no code being shared across Gmail or Google Drive. No code at all. What Gmail is doing is actually just querying Zanzibar, saying, does this person actually have access to this doc? And they're using that to improve the user experience of Gmail, simply because they can. And they don't have to couple themselves in any way to Google Drive. Super powerful if you're building like a suite of applications. This is actually a really good way to unlock way better user experience and new features that were otherwise probably not possible. But I think the largest kind of difference you get with this centralized authorization model is it actually enables you as a business organizationally to have a platform team or security team own authorization across your whole business. So what was previously bespoke code sprinkled across all of your different applications, now you can have a centralized team that just owns authorization, makes sure it's basically doing the best practices in terms of operations and security across your whole business, and you have a centralized place to audit if anything happens. All right, so that was centralized authorization. Next up is ReBAC. So ReBAC is relationship-based access control. And this one is not to be confused with ReBAC, which is role-based access control. ReBAC is actually lower level than that, and you can actually use it to implement ReBAC or any other patterns. And so what ReBAC is it's fundamentally this idea that was inspired largely by Facebook. So back to social media. When Facebook got introduced and you started to share photos on Facebook, if anyone can remember the drop-downs for sharing and permissions, they were, do you want your friends to see these photos? Do you want friends of friends to see these photos? All of these things are descriptions of people's relationships with you. So fundamentally, what permissions were to Facebook were relations, because that's what they had. They had a giant social graph. So this is exactly what relationship-based access control is. It's the idea that if you can follow a chain of relationships between a particular entity and another one, that means they have access. So I have this example up here on the slide, which is person Jimmy. There's two relationships here. On the left, there's person Jimmy is a speaker at DevConf, right? And then on the right, there's DevConf speakers have access to the speaker dinner. And you can ask the question, does Jimmy have access to the speaker dinner? And you'll follow this chain. And because you can find this chain from Jimmy to the speaker of DevConf to the speakers of DevConf have access to the speaker dinner, now you know that Jimmy has access to the speaker dinner. And this can get arbitrarily complex. So making this a little bit more concrete, this is the AuthZed playground. So this is a place where you can go and actually play with SpiceDB live in your browser without installing anything. And what I have on the one side, the left side, I think, for how you're seeing it, is basically the definition in our schema language. So this is actually writing out the models. And while we're not showing you the data that, for example, I was just using the example of Jimmy, right? I'm not showing you the data, but we can give you that graph visualization purely based off of the models that you write. So this is kind of useful when you're first getting started and trying to understand the relationships between things and how things relate. If you can actually read the code here, I'm just defining a really simple permission system where I say there are users, there's an organization, admins can be users, right, of the organization, and then there are documents. Documents belong to an organization, and you can view a document so long as you're a reader on that document, an owner of that document, or you're an admin of the org that owns that document. And it's actually this bottom line in the definition where I define this permission where you can see the pluses saying like reader plus owner plus org admin. That's the Google Plus circles. Like you actually had set semantics in Google Plus where you're combining and overlapping the sets of users that can see a thing. That is just legitimately this manifested in code. So that's how you define models in SpiceDB's ReBAC system. Next up, we'll kind of cover how you do data. And I didn't really cover it in too much depth, but this playground, it's actually running SpiceDB and our command line tool compiled to WebAssembly in your browser. So everything here is real, and these are the real interactions you could also have on your local laptop if you cracked open VS Code and installed these things using Homebrew, for example. So I can actually go to the playground and open a debug tab at the bottom and open up a console, and then load up Zed, which is our CLI tool, and create relationships. So in this first one, I'm creating a relationship that says Jimmy is an admin of the org authzed, and then I create a document that's owned by the organization authzed, and then that's basically the interaction that you can have. We also have like a nice test relationships tab where you have like an Excel-like grid for you to enter these things. But I really want to show off basically the command line interface because that will work against production systems if you need to change data or debug them. And then right below that, I'm actually showing a permissions check where I ask the question, does Jimmy have view access on this particular document? And I do it with this explain flag, which actually gives you super useful debugging output, including timing data. But you can see it actually uses that model to traverse the data that's written into SpiceDB. And it first checks a bunch of things in parallel, but it's checking to see whether Jimmy is in one of the reader groups. It checks if Jimmy is in the owner group, and then it finds an organization that's assigned to the document, and then it checks the admins of that, and then it ultimately finds Jimmy. So that's kind of an example of using SpiceDB's engine. And now I'm going to go in a little bit more detail into the engine because I think ReBAC is a little bit more powerful than most people think. Basically, most authorization systems can do that, the permissions check. That's table stakes. You need to be able to check permissions. But how about walking the graph, this relationship graph, different ways for different queries? So in here, I actually asked the question, we have these APIs we call lookup, and you can look up resources and subjects. So in here, I can actually ask the question, what are all the organizations where Jimmy has admin? And it spits out authz. Or I can ask, who are all the users that can view this document? And it spits out Jimmy. This is an example of just some of the more powerful queries you can do in the system to discover things that you didn't understand. And all these things can be written then into assertions that you can actually check into a CI/CD pipeline and then enforce at deploy time that all of the things that you expect out of this permission system, like this person shouldn't be allowed to do this thing, you should never find that this person has access to this particular thing, those all get checked before they ever get applied to a live database system. So this actually kind of takes that human auditor that would have done QA, and it turns it into unit tests that you basically get to check in and automate sanity check before you make any changes whatsoever. So that's the power of ReBAC. And I kind of wanted to summarize everything, and if there's one takeaway, I want you to take this away, which is that building app permissions is really hard, but we all have to do it. And if you're going to do one thing, it's to evaluate pre-existing authorization tooling. Stop building this yourself. I don't care if it's SpiceDB or any other tool, but you should look out for any other thing that's going to help you so that we can collaborate together to build systems that are cohesive and make sense and keep everybody secure. So with that, if you do think it's SpiceDB, you can go to these places to watch videos, learn more, play with the playground, load up any examples that I showed today and more. And if you want to learn more, you can always hit up our blog. That's where we have very technical details. So thanks. I think we have some time for Q&A, right?
Yep, we have 5 minutes.
Thanks.
Any questions? I'll hand the mic.
So I love the idea of being able to bring the assertions into your CI/CD and things like that. But oftentimes, a lot of the permissions in like a SaaS application end up much more customer user facing. So I'm not going to know what the assertions are. And also, there's not really like a deployment cycle for applying them. It's like someone's in a web form clicking around. So is authz, is this infrastructure appropriate for back-ending that kind of a system? And how does this ability to make assertions and things or do audit trails come through if it's in like a SaaS app or most interactions are through a browser?
Yeah. Okay. Do I have to repeat the question, or you got that? Okay, I'll repeat the question.
No,
I'm good. Okay.
We're good.
Cool. Basically, the idea behind this is the models are designed in such a way that when you need to make a change to this overarching structure, you're actually writing this SpiceDB schema, and that is the part that's getting that code review and getting that model checking. The SaaS applications are actually just inserting data into SpiceDB at runtime. So if you have a representative, basically data set, you can emulate all of those changes that would be happening by any of your SaaS users. And we will actually generate things for you too, and generate exhaustively like all possible traversals through the graph. So you can like just manually look through all that to check if it's sane, or use that as a starting place to create basically these assertions. Yeah.
Let's just say completely hypothetically you had an average authentication system as shown in your diagram. What's the rip and replace look like practically? Like, how do people approach it? What are you signing up for? How much tiers are shed on the way? Yeah.
So you don't have to rip and replace an authentication system, because that's login, right? The thing that SpiceDB does is it actually lets you model your own interpretation of users. And this is actually different from how Google does it internally, because they have a service that's dedicated to just giving static IDs to every type of user. But we actually let you model your own users, so you can use whatever identity service you want And the reason why we let you model that is because... Yeah, okay. I'll cover this too. A perfect example of my point earlier. But basically, we happen all after that point, and we let you model everything yourself. So if you want to treat API keys as users, you can. If you want to treat claims in a JWT out of like your authentication system, you can. And you get to model all that yourself. So it can be arbitrarily complex. Now, if you have a pre-existing authorization system, what does the process of migrating from that to SpiceDB look like? Well, we always recommend that's a progressive one. So it depends on your use case, whether you're trying to rip and replace that thing because it's a problem, or if there's a feature that you can't implement in your pre-existing one. What we recommend is take the greenfield thing first, model your new feature in SpiceDB, and then kind of bifurcate. So you use the old system and you use the new system for the new feature, and slowly over time you migrate features into SpiceDB, and you shrink that the size of that homegrown code over time. And that honestly, that's how you should do most software migrations in general. But I think it's really easy to make the sell internally to the better thing if you point out on a new feature, like, it would take us so long to implement this feature, but look, this gives us the framework to doing it safely. And then once you're using SpiceDB, it's pretty easy to keep pushing that and saying, like, let's just consolidate this over here. So that's kind of my recommendation to our customers when it comes to migrating. That answer your question?
One more question.
You can talk to me after.
So my question is more like, what's a use case that's bad for SpiceDB? What's not performant? What doesn't fit well? Like, if I was gonna say evaluate, should I use this? Give me some things of like, don't use it for this situation.
Yeah. Yep. So the really great example is something where it's entirely context driven. So there's no data that you need to reference. So something like say a lot of the policy inside of Kubernetes, for example, is a good example of something, or even just like a firewall, right? A request comes in, it has all the data it needs in the request to say whether or not I should allow access to this thing. You're not reaching out to any other kind of data store or doing anything like that. In this case, you really only need an engine. You don't really need anything else because the data is already all there. In that case, you can reach for different policy engines or policy languages that are designed just around being engines with very little state. So SpiceDB is really good at managing state and managing lots of state across lots of services. So that's just an example of when I'd say, like, hey, lean towards a policy engine versus using SpiceDB.
Quick one.
How do you recommend handling filtering use cases where you've got a large number of entities and you need to do some amount of filtering independent of security, but then also apply security policies to make sure you're only seeing data you can see?
Yeah. So filtering is actually a really hard problem, depending on how big of the data set you're working with. So those lookup APIs I was showing, where you can kind of discover all the users or all the resources, they work really well on a small scale. You say, like, hey, give me all the people that have access to this, and then you use that in like a select in query in your database, in your relational database. Eventually, that starts to fall over, even with like pagination and lots of other scaling techniques for just getting that, because at the end of the day, you can only fit so many IDs in a SQL query. At that point, you basically have to use another service that denormalizes the graph into your actual service. So it builds an index of that data. And so that is not built into SpiceDB, but Alstead does offer that. We do have a proprietary system that basically builds that index for you, streams those changes so that you can have that basically just as a join table in your database, or maybe it loads it into the permissions in Elasticsearch for you, so you can filter in Elasticsearch natively. It basically brings that filtering just fully denormalized. So once again, you're losing all the intermediaries of the graph complexity, just the end results of this person has permission to this thing, and then we keep that in sync progressively, and then you just join against that in your database or filter against that, whatever. So that is the long-term, large-scale solution to that problem. And if you're interested in that, we call that materialized, and as a paid product currently.
Great, thank you. So we have a 5-minute break before the next session starts. I'm sure Jimmy will answer some more questions if you have them after this session. But thank you again, Jimmy.